Nothing crosses this membrane without a transport protein. That is the single most expensive sentence in Unit 2. Oxygen crosses on its own. No protein, no energy. It's happening in every cell you have, right now. 3 traps live in this topic. One rule kills all 3. Give me 3 minutes. Every membrane in this course is the same object. 2 rows of phospholipids, heads out, tails in. And sandwiched between those tails is a band of pure hydrocarbon, about 3 nanometers of oil. So the question is never, is this molecule small enough? It's, would this molecule dissolve in oil? And notice what that question is about. The traveler, not the membrane. Oxygen is small and nonpolar. It dissolves into that oily core and comes out the other side. Carbon dioxide runs the same trip in reverse. The waste leaves the way the oxygen came in. No protein, no energy spent. That is how every cell you own does gas exchange. Now the beat that breaks the size intuition. Sodium is smaller than oxygen, and the membrane refuses it. A steroid hormone is many times bigger, and it walks straight in. Size is the last question you ask. An ion in water is never bare. Its charge holds a shell of water molecules around it. To get into oil, it would have to strip that shell off, and that costs more than the crossing is worth. Here's the scale of it. How fast each traveler crosses a bare bilayer, measured against sodium. The smallest traveler on the chart finishes last, by 12 orders of magnitude. That gap is what a channel is for. Water should be refused. It is polar, and polar is exactly what that core turns away. But it is tiny, and it carries no net charge, so some of it seeps through anyway, just very slowly. Cells move so much water that most of it takes a dedicated channel, an aquaporin. Both routes are real. Glucose fails both tests at once. It is large, and it is polar. The core will not have it. So the cell supplies a doorway. Still downhill, still no ATP. A carrier is not a pump. Trap 2. A membrane bag holds 20% sucrose sitting in pure water. The reflex says the sucrose diffuses out until the 2 sides even up. It cannot. The membrane will not pass it. And that is the entire reason anything happens here. So ask what the membrane lets through before you move anything. Sucrose? No. Water? Yes. Water heads toward the side with more solute because that is where free water is scarce. Trap 3. A dye spreads across a permeable membrane until the color stops changing. So the molecules have stopped, right? No, they never stop. They are moving exactly as fast as they were before. Watch the crossings. Left to right keeps climbing. Right to left climbs just as fast. Net flow, 0. Tag a few molecules and you will find them on the far side within seconds. Balanced traffic, not a parking lot. So here is the whole topic as 3 questions asked in that order. Charged? It needs a protein. Polar? It needs a protein. Only if both come back clean do you ask about size. Not everything needs a protein. In osmosis, the water moves. And equilibrium is balance motion, not stopped motion. There is no table of molecules to memorize. There is one filter, and it asks about charge long before size. Want to step through this one yourself? Links below.